In this tutorial, I'll show you how to find Extrema on the graphing calculator. So in this example, we're told to determine the intervals on which the function is increasing, decreasing, and constant, and we are to identify any Extrema in the form of y equals at a given x value. Okay, so here is a particular function that I have graphed in my graphing calculator. I hit y equals, type my function in, and I hit graph. All right, so I can see that. I might want to just sketch that over here. So it's something like this. Not an awesome sketch, but it'll just help me talk about some of these points right here. All right, so I am going to find these points that I'm exaggerating right here because these are my 3 critical points where the function's changing direction. So to do this, I'm going to go into second trace on my calculator, and I'm going to choose option 4 for a maximum, and I'm going to find this point right here. It's going to ask me a series of 3 questions. It always says left bound, right bound, guess. And essentially what you are doing is you are moving your cursor to the left and to the right to create a bound for where that maximum occurs, or an interval, so to say. All right, so I'm sure I'm to the left. I'm going to hit enter, and then it says right bound, so I'm going to move it to the right of where that maximum occurs. So it starts to come back down that hill. And then it says, you want to guess? Yeah, I want to guess. All right, so it identifies my maximum there as the ordered pair 1.52. I'm going to go to 2 decimal places, comma 2.07. Right, so I'm going to label this one down here. This one is going to be a minimum. So again, second trace, option 3 this time for minimum. Same 3 questions, left bound, right bound, guess. So I'm going to get pretty close to it, hit enter. The closer I can get, like if I had zoomed in a little bit, it probably would have been better. Enter, guess, because then I would get a more accurate minimum. But this is probably pretty good. Negative 0.31 and negative 0.31. That's going to be a minimum. And up here I have another maximum. We'll talk in a second whether it's local or absolute. So second trace, again, option 4, maximum. Enter for the left bound, move it to the right to bound it on the right with your interval, and guess. So this is approximately 1.1 and 3.0. Okay, now let's talk about where is this increasing. So where is this increasing? It's increasing here and here on those red curves. So that's going to be negative infinity to negative 1.52 union negative 0.31 to infinity. I just made an error. Not negative, to positive 1.1. Now where is this function decreasing? It's here on this interval, and again over here in blue. So decreasing, we're talking about what x values, from 1.52 to negative 0.31. And it's decreasing again, beginning up here, at 1.1 to infinity. Okay, now let's talk our extrema. So I believe I have a maximum. This one right here that I'm exaggerating, that would be a local max. And that would be y equals 2.07 at the x value 1.52. Missed my equal sign there. I have an absolute maximum, right? Because the graph never ever gets higher than this one right here. And that's a y value of 3 at x equals 1.1. And then I believe I have a local minimum. That's this point down here, which was a y value of negative 0.31 at an x value of negative 0.31.